9.5 and example 8. We are told that you can use the normal distribution to answer questions in context or real life situations. And example 8 is telling us the heights of a large group of women are normally distributed with a mean of 165. That is the mean. And a standard deviation of 3.5. And a standard deviation of 3.5 centimeters. A woman is selected at random from this group. A. Find the probability that she is shorter than 160 centimeters. Of course, when we are talking about the height is normally distributed within a mean of 165 and a standard deviation of 3.5. Of course, that is it, because this one is always the variance. Part A of the question is, find the probability that a height of a certain woman is below 160 centimeters. Of course, 160 becomes our unfamiliar boundary, and the mean is here, and the standard deviation is there. So if we would want to rewrite this one in terms of Z, we are going to have the probability of Z, of course, less than our unfamiliar boundary 160 minus 165, everything over 3.5. And you work out this, then you will find the probability of Z less than negative 1.4285. Negative 1.4285. That is what you get after you do that operation. Having done that, it is important to always bring a model, diagrammatical representation of the situation on the ground. Yes, our Z is negative, you can see it. So if this is 0, then we have negative 1.4285. So we are looking for this particular region whose area is not known. At the end of the day, it is important to note that if you have this symmetrically, then we have 1.4285. And this region, as much as this one is having the same area A, this one is having the same area A. And what can we say? At that point now, if we talk about the probability of the region less than this, which is the same when we add with the region greater than that boundary, we should always get a 1, meaning that the probability of Z less than 1.4285 plus the probability of Z greater than 1.4285 should give us a 1, because let's talk about the whole model. That means what? The probability of Z less than 1.4285 is 1 minus 1 minus is going to be equals to 1 minus whatever we shall find here. But before we go further, let us look at the nature of this presentation. Z less than 1.4285. So this is our boundary. We can take this to be our small z, the boundary, 1.4285. Let us see if we go to the table, can we find that? Can we find our area there? Can we find our area there? Yes, let's see what we can. Now, page 201, 1.42. 1.42 as our small z. 1.428. 428. 1.428 is very close to 1.43, and the area is 0.9236. 0.9236. So that means this one is 0.9236. Having found that, we are talking of what is this area, because our question is within this probability, because it's supposed to be less than negative 1.4285, which is, and we talked about that area is equals to that area. So we are looking for this, meaning that if you get the area of a region of Z less than 1.4285 to be 0.9236 plus the probability of Z greater than 1.4285 should actually give us 1, and this region is, you can highlight this, that region, this region is actually this region, is talking about the A. So if you want to make it the subject of the formula, meaning that the probability of Z greater than 1.4285 is equals to 1 minus, of course, 0.9236, 0.9236, and then the probability of that region, which is 1.4285, is what we find there, 0.0764. 0.0764. 0.0764. So what exactly are we saying? We are not talking about specifically this region, though this one is by symmetry equals to what we have. So our answer to that question is the probability of Z less than negative 1.4285, and this one is equals to the probability of H less than 160 is exactly what we have found to be 0.0764. 0.0764. And that is the end of that particular question. And I would wish to work out part B in a different video because it's going to be long. So that one ends there. Let's see what we can do in part B in the next video, right?